Hello everyone, welcome to Math 115, College Algebra. So in this section, I want to talk about linear equations in one variable. This is section 2.2 from your textbook. So we're going to go over how to solve equations in one variable algebraically. We'll talk a little bit about how to solve a rational equation in one variable, and then we'll spend a little more time on this when we look at solving other equations in a later section. We'll look at how to find a linear equation, how to come up with the equation of a line. And then we'll also look at how to determine whether two lines are parallel or perpendicular, and how to find equations given some information, like one line is parallel to another line and it passes through a particular point, something like that, and coming up with the actual equation. Okay, so to start, when we're trying to solve linear equations in one variable, basically we're trying to isolate the variable, right? We're trying to get the variable, usually it's x, but it could be anything, on one side of the equation, trying to isolate it. And a linear equation has the form, which we can see here. So it has the form ax plus b equals 0, where a is not equal to 0, right? So there has to be an x term there. So in other words, the thing that makes this linear is that the x is raised to the 1 power, right? The exponent is a 1 there. So before we get into solving them, let's talk about how to classify linear equations. So we're going to classify them based on solutions, and there's basically three types. The first type is something called the identity. And this type of linear equation is going to be true for all values of the variable, basically all the values of x. So let me give you an example. Let's say I have something like this. I have 2x plus 3x plus 7 equals 5x plus 4 plus 3. If you try to solve this, right? So on the left-hand side, we'll combine like terms. 2x plus 3x is 5x. On the right-hand side, I can also combine like terms. I can combine the constant, so 4 plus 3 is 7. So this would be 5x plus 7. Then I want to get to x's to one side, so I'll subtract 5x. Whatever I do to one side, I'll do the other side. Notice that cancels now, right? The x's cancel, and I'm left with 7 is equal to 7. And then I could also go a little further. I could say, well, let me subtract 7 from both sides. Again, whatever I do to one side, do the other side. And ultimately, I'm going to end up with 0 is equal to 0. So when I say 0 equals 0, this is always true. Right? So if you ever try to solve a linear equation and you end up with 0 equals 0, which is always true, what this means is that any x value will make the original equation true. So in other words, this original equation that I wrote here, this is true for any x value. Anything that I make x. X could be 1, x could be 5, x could be negative 4/3. Any x value will make that equation true. Okay, if you end up with this 0 equals 0. So let me write that here. So any x will make the original equation true. Okay, so that's called an identity. These special cases aren't going to come up too often. Actually, the next classification, conditional, which means the linear equation will be true for one variable. This is the most common case, right? We're actually going to solve it for a particular value of x. So an example of that, let's say I have 4x minus 3 is equal to 3x plus 5. So let me try to get the x's on the left-hand side. So I'll subtract 3x from both sides. And then I'll do the same on the same step. Let me get the constants on the right-hand side. So I'll add 3, right, to make it as 0 here. So negative 3 plus 3 is 0. But whatever I do to one side, I have to do the other side. And notice, so now I have 4x minus 3x. That's going to be x. And then this is 0, right? This is 0, and then 5 plus 3 is 8. So that's my solution, right? X equals 8. So that would be a conditional. The classification would be conditional. I actually solved it, and I got one answer. I got an answer for X. Okay, another way of saying that, if X equals 8, then the equation is true. By the way, you can check that by plugging it back into the original equation, right? So where I have an X, I could plug in an 8. So remember, it was 4 times X, so 4 times 8 minus 3. Does that equal, I'll do a question mark here, 3 times 8 plus 5. So 4 times 8 is what, 32 minus 3. Does that equal 24 plus 5? Well, yeah, this is 29. That equals 29, right? So it checks. So that is our actual solution. And again, that's the most common case when we're solving linear equations in one variable. We're going to get an answer. Okay, the last possibility is you could have something like this. What if I have 3x plus 4 is equal to 2x plus x plus 7. Okay, and I try to solve this. So again, I combine like terms. So I can't really do anything on the left-hand side. On the right-hand side, I can combine the x's, right? 2x plus 1x is going to be 3x. Try to get the x's together, so I'll subtract 3x from both sides. But then notice when I do that, right, I'm going to have 4 is equal to 7, which is never true. In fact, you can go even a little further. I can subtract, let's say, let me subtract 4 from both sides. And I'm going to have 0 is equal to 3, which is never true, right? It's inconsistent. This is never true. So therefore, what does that mean for the original equation that I was given? It means that there's no x value that will make that equation true. It'll never be true for any x value. Okay, so I'll write no x value will make the original equation true. Okay, so, but again, in most cases, it's going to be a conditional equation, right? We're actually going to get an x value. But the other two cases are kind of like special cases. Okay, so in general, how do I solve an equation, a linear equation in one variable for the particular variable? The whole goal is just to isolate the variable, okay? So in this example here, let's do a few of these. Let's say I want to solve this equation for x, right? So the first thing I want to do is I want to distribute in the -2. Right? I want to multiply or distribute in the -2 on the left-hand side. So if I do that, I have -2 times 3x, which is -6x. -2 times -1, which is +2. I still have a plus x there, equals 14 minus x. Now we try to combine like terms, right? So are there any like terms on the left-hand side? Yeah, I have -6x plus 1x. If I combine those, so -6 plus 1 is -5. This is -5x plus 2 is equal to 14 minus x. Now I want to get the x's onto one side of the equation, right? Typically the left-hand side, but it doesn't really matter. And the reason why is I want to ultimately isolate the x. So to do that, I'm going to add x over here. Why do I do that? Because -x plus x will give me 0, right? That gives me 0. But whatever I do to one side, I have to do the other side. So I have to add x to this side as well. And then -5 plus 1 is -4x plus 2 is equal to 14. And now to isolate the x, I need to get rid of that 2. So how do I get rid of it? Well, to get a 0 there, I can subtract 2. Right, so that'll be gone. But again, whatever I do to one side, I have to do the other side. So now I have -4x is equal to 12. And then finally, to get x by itself, and what I mean by x by itself is I mean 1x. I want the coefficient of the x to be a 1. Right now it's being multiplied by negative 4. So how do I get a 1 there? Well, if I divide by negative 4, or multiply by by 1 over negative 4, by negative 1/4, but it's easier just to think of it as divide by negative 4, then that will give me a 1 here, right? But again, whatever I do to one side, I have to do the other side. So in this case, I'm going to get an answer x, it's isolated, and then 12 divided by negative 4 is negative 3. Now that the x is isolated, I can just read off the answer, right? X must be negative 3. What type of a solution was this? Well, since we solved it and got a value for x, this is a conditional solution, right? Conditional would be the classification. Okay. What if we have a rational equation? So something like this: 7 over 2x minus 5 over 3x equals 22 over 3. The best way to handle these is to try and clear out the fractions. And the way that you do that is you multiply both sides by the lowest common denominator. So we're going to multiply both sides by the LCD, right? The lowest common denominator. Now, what's the lowest common denominator? Well, it's the lowest common multiple. So the lowest common denominator is always the lowest common multiple of the denominators, which in this case is 2x, 3x, and 3. So if you want to, usually you can do this in your head, but if you want to write this out carefully, we could do this, right? So I have 2x, 3x, and then 3. The 2 I can't factor any further. It's already a prime number, so I can write this as 2 to the 1. There's no 3 in that first group, so I can write a 3 to the 0, and I have an x to the 1. For the second grouping, there's no 2, so I'll write 2 to the 0. 3 is already prime, so I can't factor any further. 3 to the 1, and then x to the 1. And for the third group, I have no 2. I have a 3 to the 1, and I have no x, so I write x to the 0. And then remember, to find the LCD, we take each, which is the LCM, we take each factor, right, the 2 to 3, the x, the greatest number of times it occurs in either of the factorizations. So here we see that the 2 occurs once, 0, 0. So we take it once, right? That's the greatest number of times. The 3 occurs 0, once, so it's a tie, so we take it once. That's the greatest number of times. And x occurs once, 0, so we take it once. So basically, the LCD is going to be 2 times 3 times x, which is 6x. Okay, now that I have that, I'm going to multiply both sides of the equation by 6x. All right, so I'm going to have to distribute in that 6x, right, on the left-hand side, and then the same thing on the right-hand side. Multiply it by 6x. Okay, so what does this mean? Well, remember, 6x you can think of as 6x over 1 if you want to write it as a fraction. So that first term, here I'll do it over here, is really saying 6x over 1 times 7 over 2x. So we can, first of all, we can cancel things, right? The x's will cancel, and then a 2 cancels with, goes into 6 3 times, so I can put a 3 there, right? You could write 6 as 2 times 3, and then the 2's cancel. And then you're left with 3 times 7, which is 21, over 1 times, there's nothing left except a 1 there, right? Well, over 1, which is just 21. So this first term is going to be 21. Minus, and then I have 6x over 1 times 5 over 3x. Again, the x's cancel. 6 you can write as 2 times 3. The 3's cancel. So I'm left with just 2 times 5, right? 10 over 1, which is 10. Okay, and I already have the negative there, right? So minus 10. And then on the right-hand side, I'm going to have the 3, I guess, will cancel with a 3 from the 6 here, right? So I'm left with a 2. And I still have the 22, so I have 2 times x times 22, which is 44x, right, over 1, which is 44x. Okay, good. So our goal is to isolate the x. We're almost done, right? On the left-hand side, I can subtract this, right? So this is going to be 11. If you want to put the variable on the left-hand side, you can just move it. Since these are equal, I could just write this as 44x equals 11, right? I can do that since they're already equal. And then to get x by itself, I want 1x, so I have to divide by 44. So x here is going to be 11 over 44. That would be my answer. Okay, we're going to... actually, I can simplify that too, right? So it turns out 11 goes into 44 4 times, and it goes into 11 once, right? So this is the same as 1/4. We should really simplify it if we can. So x equals 1/4 would be the answer in this case. Now, we're going to learn when we talk about section 2.6 and solving other types of equations that you should really check this. Whenever you have a rational equation, you should check it to make sure that the solution is correct, because sometimes you can introduce solutions that will make the equation undefined. So in this case, really the only problem would be if x is 0, right? Then you can't divide by 0. This would be undefined. And we got 1/4. So this will be fine, and you could check it, but it'll work in this case. Okay, let's do another example. So same thing. I want to solve this rational equation for x. So I'm going to find the LCD. Well, in this case, I have I have x minus 6 and I have x, right? And I can't factor them any further. So basically, the way to think about this is, again, if I want to include x here, I can say this is x to the 0 times x minus 6 to the 1. And in this case, I have an x to the 1, and I don't have any x minus 6's, so I can write this as x minus 6 to the 0. So I want to take the x to greatest number of times, which is once. I want to take the x minus 6 to greatest number of times, which is once. So it turns out that the LCD is just x times x minus 6. Okay, so now if I multiply both sides by that, let me write this in front. So x times x minus 6 times 5 over x. Okay, on the left-hand side, what's going to happen? Well, the x minus 6's are going to cancel, right? These are going to cancel, and I'm just left with 3x over 1, which is 3x. On the right-hand side, the x's are going to cancel, and I'm left with 5 times x minus 6. Okay, so now going further, I need to distribute in that 5. Bring the x's, let's just bring them to the left-hand side, so I'll subtract 5x from both sides. So I'm going to have negative 2x is equal to negative 30. And then finally, to get x by itself, all right, I want a 1x. Since it's being multiplied by negative 2, I'm going to divide by negative 2. And that will give me x is equal to 15. And that's the solution. So if x is 15, then that'll make that rational equation true. Okay, a few more of these. So same process, find the LCD and then multiply both sides of the equation by the LCD. So in this case, to find the LCD, well, I have x minus 3 as a factor, and then x minus 3, and then a 2. So again, I want to take each factor the greatest number of times it occurs in either of the factorizations. If you want to put in the 2's here, you could say this is 2 to the 0. This is 2 to the 0. And then if I want to put in an x minus 3 here, it'd be x minus 3 to the 1. Sorry, x minus 3 to the 0, right? If I don't want an x minus 3 in that third factorization. So basically, I need to take the 2 once, in the x minus 3 once. and that will be my LCD. Okay, so let's multiply both sides by that. So I have 2 times x minus 3 times the left-hand side. And then 2 times x minus 3 times the right-hand side. Okay, on the left-hand side, if I multiply this, see how the x minus 3's are going to cancel? I'm just going to end up with 2x. And the right-hand side, I have to distribute this. So when I multiply 2 times x minus 3 times 5 over x minus 3, the x minus 3's will cancel, and I'll get 10, right? And if I multiply by the second term, I'm going to get minus 1 times, like the 2's will cancel, and I still have an x minus 3 here. And remember, be sure you put that in parentheses, right? It's minus 1 times that. Ultimately, we're going to have to distribute in the negative 1. So let me do that now. I'll distribute in this negative 1. So that's just going to change the signs, right? It'll be negative x, and then negative 1 times negative 3 is plus 3. I'll combine like terms. So this will be 13. I'll write it as negative x plus 13. I'll bring the x's to the left-hand side. So I'll add x to both sides. So I'm going to get 3x is equal to 13. And then finally, let me finish it over here. I need to divide both sides by 3. So in this case, x is equal to 13 thirds. Okay, and then let's do one more. Okay, this one, the LCD is going to be a little bit harder to find, but not too bad, right? So let's look at all of our factors. The first case, I just have x minus 2. I can't do anything else with it. In the second case, I have x plus 1. And then notice here, in the third case, if you factor this, so this is a quadratic expression, right? Since the coefficient is a 1 here, I can use the BC rule. So xx. I want two things, and multiplied will give me negative 2, and added will give me negative 1. Well, negative 2 and positive 1 will work. Okay, so in this case, if I look at my x minus 2's, it occurs once here, 0 times here. I didn't write it to the 0 power. I'll just say 0 times there, and once here. So the greatest number of times is once. I take it once. And then the x plus 1 occurs 0 times here, once here, and once here. So the greatest number of times is once. So my LCD is just that product. It's just x minus 2 times x plus 1. So now I multiply both sides by that. And notice that, right, when I divide by x squared minus x minus 2, I'm going to write it in factored form, so it's easy to cancel things. So this is really just 1 over x minus 2 times x plus 1. Okay, so if I distribute this in, the x minus 2's cancel, but I'm left with, I still have 2 times x plus 1. If I multiply by the second term, the x plus 1's cancel, but I still have 1 times x minus 2. And then on the right-hand side, the x minus 2's and the x plus 1's cancel, and I just have 1 times 1, which is 1. So let me distribute in the 2. So I'm going to have 2x plus 2. Distribute in the 1, which is not going to do anything, right? So it'll still be x minus 2 equals 1. I'll combine like terms on the left-hand side. So 2x plus 1x is 3x. Oh, I have another negative x here, right? So, wait, did I goof this up here? Oh, no, I made a mistake here. So this is, let me go back here. 1 times x is x, 1 times negative 2. I just made a little typo there, right? It's negative 2. So actually, the negative 2's, the negative 2 and the positive 2 are 0. That's gone. The x's I can combine. 2x plus x is 3x, right? That's equal to 1. And then finally, to get x by itself, I need to divide by positive 3, right? So x is equal to 1/3. That will be the solution. And again, in a later section, I'll remind you how to be a little more careful and to check some of these solutions. In this case, we're fine, but we'll learn how to check them later on. Okay, so that's solving equations. Now let's switch gears a little bit and talk about how to find a linear equation, like basically how to come up with the equation of a line. So there's many different forms that we can use for the equation of a line. The most familiar, the one that you guys are most familiar with, is y equals mx plus b. Right? So we have y equals mx plus b, where m is the slope, right? So the coefficient of the x term is the slope. And then the b, we usually call the y-intercept. You have to be a little careful. It's really the point 0, comma b, right? Because it's really an ordered pair. That is the y-intercept. But a lot of times people, when I do this myself, we just say b is the y-intercept. But really the y-intercept is a point, right? 0, comma b. Okay, remember what slope means, right? It refers to how slanted the line is. So if we have something like this, where the line is doing something like that, then this represents a positive slope, right? So if you read the graph from left to right and it's going up, it's slanting upward, this is a positive slope. So we could say the m is greater than 0, right? It's a positive slope. If you're reading from left to right, remember these are our Cartesian coordinate system, right? X, y, x, y. Let's say the graph does something like this. So it's a line that goes down. This would be a negative slope. So in this case, m is less than 0. And then 2 more cases. See if I can fit it in here. Let's say I have a line that is flat, right? The output is a constant. So something like this. So since there's no steepness to that line, right? Slope is flat. That means the slope is equal to 0. So if you have a line that's horizontal, like a flat line, that means the slope is 0. And the last case is you could have like a vertical line. So in that case, because it's like, it's super, you could say it's almost like infinitely steep, but the best way to say this is when you actually calculate the slope or try calculating it, I'll remind you of the slope formula in a minute, then in this case, the slope is undefined. So if you have a vertical line like this, the slope is undefined. And you'll see why. It's because you'd end up dividing by 0, and we cannot divide by 0 mathematically. So horizontal line, these are like the two special cases. Horizontal line, slope is 0. A vertical line, the slope is undefined. Okay, so how do we actually calculate the slope? Let's say we're given 2 points and we want to calculate the slope. Well, the slope, remember, we can think of this several different ways. We can think of it as like the change in the y value, like the change in the output, over the change in the x value, or the change in the input. Okay, sometimes people will write the change in y as the rise and the change in x as the run. So you can think of it as rise over run. Another way of writing change is delta. So we could say delta y over delta x, right? That's the same thing as change in y over change in x. Or explicitly, remember, change always means like final minus initial. So I can write this as like y2 minus y1 over x2 minus x1 if I know the coordinates directly. So for instance, we're asked in this question, find the slope of the line that passes through the points -2, 6, which I'm just going to label the ones, x1, y1. It doesn't really matter which one you label the ones and which one you label the twos. And then through this point, 1, 4. So what's the slope of the line that passes through those points? Well, we can just use our formula here and calculate it, right? So the slope is going to be y2 minus y1 over x2 minus x1. So y2 is 4 minus y1 is 6 over x2 is 1 minus x1 is, be careful, so I'm going to write parentheses here, -2. So 4 minus 6 is -2. 1 minus -2 is 1 plus 2, which is 3. So that's my answer. The slope in this case would be -2/3. So this line, if you were to plot it, would be slanting downward, right? Reading left to right. Okay, what about this case? Determine the slope in the y-intercept of this line. Well, notice this is in the form that we want it to be in, right? It's in the slope-intercept form. It's in the y equals mx plus b form. Right, so I can just match things up, right? The m is the -3/4. So that's the slope. It's -3/4. And then the b, don't forget the sign there, is -4. But again, you have to be really careful. The y-intercept, remember, is 0. Even though we say b is the y-intercept, it's really 0, comma b, right? It's an ordered pair. So really the y-intercept is 0, comma -4. That would be the y-intercept. Right? So in that case, we got it just by matching it. We put it in the form y equals mx plus b. It already was in that form. And then we can cherry pick out the slope, the m, and then cherry pick out the b. Okay, so if it isn't in that form, you just put it in that form, right? So in the next example, determine the slope and y-intercept of this line. So put it in the form y equals mx plus b. In other words, how do I do that? I need to solve this for y. So I will, I'll get rid of the 6. So I have -y is equal to 3x minus 4. And then I need to get y, not -y, but y. So I would need to divide both sides by -1. By the way, the other way you could do this is you could bring the y to the right-hand side and bring all the other terms to the left-hand side. That will also work. But let me just divide by -1 here, which means both those terms on the right-hand side need to be divided by -1, right? So this is y equals, I'm going to have, here, I'll write this out carefully the first time. So I really have this, right? 3x over -1, and then I'll write it as plus -4 over -1. So this becomes y is equal to 3 divided by -1 is -3. So this is -3x. And then -4 divided by -1 is +4. So this is +4. So remember, this is the m. Okay, so that's easy. So we know the slope here is going to be -3. And then this is the b. So we know our y-intercept is going to be the point 0, comma b, so 0, comma 4. That would be the answer. Okay, so that's the most common form that we use is the slope-intercept form, right? Y equals mx plus b. But there's other forms that are sometimes useful, especially when trying to write the equation of a line. So another form that's sometimes useful is called the point-slope form of a linear equation. And it has this form right here. So it's y minus y1 equals m times x minus x1. where again, the m is the slope, and then x1, y1, so this point x1, y1, is just a point on the line. So it's a point that the line passes through. Okay, so this can be useful when trying to find the equation of a line. So in other words, let's do example 9 here. Find the equation of a line passing through the point 2, 5, which has a slope of 4. So they're giving us some information, right? They're telling us the slope is 4, and it passes through this point. So they're giving us an x1, y1, right? This x1 is a 2, and the y1 is a 5 in this case. So now if we put this into the point slope form, I have y minus y1, which is 5, equals the slope 4 times x minus x1, which is 2. And then typically you write your final answer in the y equals mx plus b form, right? The slope y-intercept form, slope-intercept form. So to do that, let me just distribute the 4. So I have 4x minus 8. And then I'm going to get y by itself, so I'm going to add 5 to both sides. So I have y equals 4x, and then I have minus 3. Okay, and that's the equation of the line, right? That has a slope of 4 and passes through the point 2, 5. So often this point slope form here is very useful for finding the equation of a line. However, another way you could do this is the following. You could assume, okay, we know ultimately it's going to have this form, y equals mx plus b. So one thing you could do is, okay, I don't know what b is right now, but I do know m, right? So I could plug in m. M is 4. And then to find b, I could use the argument, well, this point right here, so this point 2, 5, has to satisfy this equation, right? Because it lies on the line. So if I plug in 2 for x and 5 for y, that will allow me to find b. So that's another way of finding the equation of a line. So now I can say, okay, y is 5, x is 2, and then so I have 5 is equal to 8 plus b, and then to get b by itself, I'm going to subtract 8. So b here is going to be negative 3. And now my line, I have the equation of my line, right? It's y equals mx, so the m was 4, and then plus b, but b is minus 3. So you're going to get the same answer. So sometimes you could solve the equation using the point slope form, or you could just use the slope intercept form, right? Either way will work. Okay, what if we want to find the equation of a line passing through 2 points? Well, we can do that, but first we need to find the slope, right? So I'll write find slope first. So let me label these. I'll label the 3, 4 as x1, y1. I'll label the 0, negative 3 as x2, y2. So remember the slope is going to be y2 minus y1 over x2 minus x1. So this will be negative 3 minus 4 over 0 minus 3. So this is going to be negative 7 over negative 3. The negatives cancel, right? It'll give you a positive. So this is just going to be 7/3, positive 7/3. Okay, now we want to find the equation. So we have the slope. We could do it either way. We could use the point slope form. We could use the slope intercept form. Let's just use the point slope form. So I need to choose one of these as my point. Let me just, since this is the first one, let me choose this one. So this is going to be like my x1, y1 when I plug into the point slope form. So I have y minus y1, which is 4, right, equals the slope, 7/3, times x minus x1, which is a 3. Let me distribute this. So y minus 4 is equal to 7/3 times x, which is 7/3 x. And then 7/3 times minus 3 is going to be minus 7, right? Because the 3 is going to cancel. And then finally, if I add 4, bring it to the other side, I'm going to get y is equal to 7/3 x minus 3. Okay, the other way you could have, actually, one thing you could have recognized here is notice that this point, one of the points that the line was passing through was 0, minus 3. This is the y-intercept, right? So what this is telling us here is that the b is a minus 3. We found the slope earlier, right? We found the slope was 7/3. So then we could have just used the slope-intercept form and said y equals 7/3 x plus b, but b is minus 3, right? And we would have got exactly the same information. So as with anything in math, there's usually multiple ways you can solve a problem. Okay, the other form that isn't talked about too often, but I think it's important, so I want to go over it. It's called the standard form. So the standard form of a line has the form ax plus by equals c, where a and b are not both 0. One of them could be 0, but not both of them, right? And that would be also a way of writing the equation of a line. So in the first case here, it says write y equals 4x minus 7 in standard form. So we just want to manipulate this so that we have an x term first, then a y term, and then the constant is on the right-hand side. So to do that, I basically just need to move the x term to the left-hand side, so I'll subtract 4x from both sides. And then I can write this as, I need the x term first, right, minus 4x, plus y. Remember, in this case, there's always a 1 there, right? So really it's saying like the b is a 1, equals, and I still have a negative 7 on the right-hand side. So this would be that linear equation, that equation of a line written in standard form. And basically it's telling us that a is equal to negative 4, b is equal to 1, and c is equal to negative 7. Okay, why do I think that this is sort of a useful form, although we don't hear about it more often? I think it's useful when we're talking about the special cases of the graphs of a horizontal line and a vertical line. Let me explain. So let me go to the next page here. Let's say I want to graph the equation x equals negative 3, right? So I have a Cartesian coordinate system. I'll draw it over here. And let me do some vertical tick marks here. Okay, so first thing, let's look at what this equation looks like in standard form. So remember, in standard form, right, it's ax plus by is equal to c. So I could write this as 1x. There is no y term, right? So I could write the b as 0 times y, because that will still equal 0. And that's equal to negative 3. And that's okay, because remember, in standard form, as long as a and b aren't both 0, one of them could be 0. Okay, why is this helpful? So now let's make a little table of some values that we can plot so we can figure out what this line looks like. So I have x values, I have y values. Notice here, it doesn't matter what I plug in for y. right? I'll start with negative 2. If I plug in negative 2 for y, I'm going to get x plus 0 times negative 2 is equal to negative 3. 0 times negative 2 is 0, right? So that's gone. So really it just gives me x is equal to negative 3. If I plug in negative 1 for y, if I do that, I'm going to get still x equals negative 3, right? If I plug in 0 for y, I'm going to get x is negative 3. If I plug in 1, if I plug in 2, for any y value I use, I'm always going to get the solution x equals negative 3. So let's plot those. So if I plot negative 3 comma negative 2, I'm going to move to the left 3 and then down 2. So it's right here. Then negative 3, negative 1 is here. Negative 3, 0. Negative 3, 1. Negative 3, 2. Notice that if I plot this line, I'm going to get a vertical line that looks like this. Okay, so x equals negative 3 is a vertical line. And it happens to pass through the point here, negative 3 comma 0. What's true about the slope? Well, it's infinitely steep, right? So basically we would say that the slope is undefined. Remember, for a vertical line, the slope is always undefined. By the way, you could show that by plugging in 2 points, right? If I plugged in, let's say I calculate the slope, and I use the first 2 points here. So I use negative 3, negative 2, and then negative 3, negative 1. This is x1, y1, x2, y2. I'm going to get y2 minus y1 over x2 minus x1. If you do that, so negative 1 minus negative 2 is negative 1 plus 2, which is 1. But in the denominator, I get negative 3 minus negative 3, which is negative 3 plus 3, which is 0. This is undefined, right? You can't divide by 0. That's why the slope is undefined for a vertical line. So what this is telling us is, in general, and I'll write this out over here. So in general, an equation of the form x equals a, so x equals a constant, which is what we had, right? X equals, remember we had x equals negative 3, so a is negative 3, just some constant. So anytime you have that form, x equals a, that's going to be a vertical line. Basically, that passes through the point a comma 0. So a comma 0. Right, in this case, it was negative 3 comma 0 that passed through. Okay, and then there's going to be a similar result for a horizontal line. So if we have the equation, say y equals 4. I'm kind of running out of room here, but let me draw like a new coordinate system here. So x, y. I'm going to put it in standard form. So in standard form, remember it's ax plus by is equal to c. So now the a is 0, right, because there's no x term. The b is 1, and then the c is 4. And now it doesn't matter what I choose for my x values. I'll just do negative 2, negative 1, 0, 1, 2, just a few of them. If you plug those in, because I have 0 times x, it's always going to give me 0. And then when I get my solution, I have y equals 4. It's always going to be y equals 4 for my solution here. So if I plot those points, negative 2, comma 4. I go to the left 2 and up 4. That'll be here somewhere. Negative 1, 4, 0, 4, 1, 4, 2, 4. Notice now this is going to be a horizontal line. So x equals 4 is a horizontal line. And what is the slope of a horizontal line, right? It's flat, it has no slope, so that means the slope is 0. And again, if you were to choose 2 points and plug it into the slope formula, y2 minus y1 over x2 minus x1, you're going to find you're going to get 0 over some number, which is 0, right? So the slope is 0. So I can write this in general again. So in general, an equation of the form y is equal to a constant, usually we just say b, is a horizontal line. That's always going to pass through 0 comma b, right? The y-intercept. Passing through 0 comma b, right? In this case, it passed through 0 comma 4, that line, that point right there. Okay, so x equals a constant is a vertical line, slope is undefined. Y equals a constant, when you plot it, when you graph it, it's going to be a horizontal line where the slope is equal to 0. Okay, let me now remind you of whether graphs of lines are, if we have 2 lines, are they parallel or perpendicular? So what does it mean for 2 lines to be parallel? Let me draw a picture right here. So let's say I have a line, so this is x, this is y. I have a line like this and a line like this. So this one has the form, say, or has the equation y equals m1, like slope 1x plus b1. And this one has the form y equals m2 x plus b2. So if 2 lines are parallel, that means they never intersect. So that's the picture I just drew. So they never intersect. If, you know, like those lines, if they go on forever, they'll never intersect. And what does that mean in terms of the slope and the y-intercepts? It means they have the same slope and technically they have to have different y-intercepts, right? Otherwise they'd be exactly the same line. So have same slope but different y-intercepts. Okay, so in this case, m1 would equal m2, but b1 would not be equal to b2, right? Same slope, different y-intercepts. All right, what does it mean for 2 lines to be perpendicular? So in that case, they would intersect, but in a special way where they would meet at a right angle. It's hard to draw this exactly. So in other words, in this case right here, this angle is a right angle, right? It's 90 degrees. Okay, so they would intersect. They're perpendicular if they intersect to form a right angle. So if one of them has the form, again, I'll write y equals m1x plus b1, and then the other one has the form y equals m2x plus b2. How do I know if they're perpendicular? It has to do with the slopes, and the condition is if you multiply the slopes together, if I multiply m1 times m2, that has to equal -1 for them to be perpendicular. Okay, so m1 times m2 has to equal -1 for perpendicular lines. Another way to say that, or I could write it this way, I could say that the slope of the second line, m2, has to equal -1 over m1, right? It's negative the reciprocal of the first slope. And you can see that from here, right? All I did was I can solve this for m2, right? I divide both sides by m1, and I'm going to get m2 is -1 over m1. Okay, that's the condition for the two lines to be perpendicular. Okay, so let's do a little bit with that. So let's first figure out whether these two lines that are given are parallel, perpendicular, or neither. So the way to answer that is put them in the slope-intercept form, right? Put them both in the y equals mx plus b form. And then we can just look at the slopes, look at the y-intercepts, and see what's going on. So I want to put them in the y equals mx plus b form. So how do I do that? I need to solve both of them for y, right? So in this case, I'll add x to both sides. And then I need to divide by 2, right? Divide both sides by 2. So this is going to be 1 over 2 times x plus 10 over 2, which is 5. Okay, so that's the first case. And then the second case, again, I want to solve for y. So first of all, since these are equal, let me put the y on the right-hand side, on the left-hand side. So I'll just rewrite it again. Right, since they're equal, I can do that. So 2y is the same as x plus 4. And then I need to solve for y, so I'll divide both sides by 2. So I'm going to get y is equal to 1/2 x plus, and then 4 over 2 is 2. So this is like my m1. This is like my b1. This is like my m2. This is like my b2. Right, so notice here that m1 is equal to m2, right? They're both 1/2. And then b1 is not equal to b2. So they have the same slope, but different y-intercepts. So what does that mean? It means these two lines are parallel. Right, if you were to plot these lines, you would find that they're both parallel. They never intersect. Okay, what if I want to find the equation of a line parallel to another line? Well, in that case, okay, so this example says, determine the equation of the line in slope-intercept form that's parallel to the line 5x equals 7 plus y and passes through the point 3, 5. So what we first need to do is we want to find the slope of our new line that's parallel to the original line, but we know that the slopes have to be equal, right? Our new line, the slope of the new line has to equal the slope of the original line. So what I would do first is find the slope of the original line. How do I do that? Let me just put it in the y equals mx plus b form. So again, I'm going to write this as, I'm going to write the 7 plus y on the left-hand side and 5x on the right, just so I have the y on the left to start. And then if I subtract 7, this is y is equal to 5x minus 7. So what is this telling us? It's telling us that the slope of the original line, I'll call m1, is 5. Right? So m1 is equal to 5. Okay, I want to find the slope of the new line. Let's just use the point slope formula. So I know that the new line has to have the form y minus y1 equals m times x minus x1, right? I'm going to use the point slope formula. Well, I know my point, right? It's got to pass to the point 3, 5. So 3 is like my x1, 5 is my y1. And I know the slope. The slope here, I'll call it m2 because it's my new line, is going to be the same as the original line, which is 5, right? Because I want it to be parallel. So now if I plug into this point slope form, I have y minus 5, right? Y minus 5 equals, the slope has to be 5 times x minus 3. Distribute the 5. So I'm going to get 5x minus 15. And then finally, I'll solve for y. I'll add 5 to both sides. And I get y equals 5x minus 10. And that would be the equation of the line that's parallel to this given line and passes through that point. Okay. We can also do this now if we want to find a new line that's perpendicular to the original line. So in this case, this last example here, determine the equation of a line in slope-intercept form that's perpendicular to the original line, which is the same as before, right? 5x equals 7 plus y, and passes to the point 3, 5. So now what I want to do is just like before, find the slope of the original line. Oops. We already did that, but let's just do it again because it happens to be the same equation. Right, so I can either bring the 7 plus y to the left to start with, or if you want, you could just do this. Right, I could subtract subtract 7 from both sides, and then I have y equals 5x minus 7. That's the same thing as writing y equals 5x minus 7. Right, it doesn't matter what side I write it on. So I can switch sides later if I want. In either case, we know that m1 again is 5. Right, the slope of the original line is 5. Okay. How do I find the new slope for the perpendicular line? Well, to find new slope, I'll call it M2 for the perpendicular line. Remember, it has to meet, it has to satisfy this equation that m1 times m2 is equal to negative 1. Or another way of saying it is m2 is negative 1 over m1, right? It's negative the reciprocal of the first slope. So m2 here must be negative 1 over positive 5, which is negative 1/5. So now that we have the slope of the new perpendicular line, I can use the point slope form and find the equation, right? So I know that I want this form. Y minus y1 is equal to m times x minus x1. Okay, so, and I know the point, right? I want it to pass through 3, 5. So this is like my x1, y1, just like before. So I have y minus 5 equals the slope, which you know now has to be negative 1/5, right, for the perpendicular line, times x minus x1, which is 3. Distribute in the negative 1/5. So negative 1/5 times x is negative 1/5 x. And then negative 1/5 times negative 3 is positive 3 over 5. And then finally, oh, I have the sign wrong here, right? Let me fix that. This is still negative y minus 5, right? I want to add 5, right, to get y by itself. So add 5, How do I do that over with the fractions? Well, 3/5 plus 5, remember that's 5 over 1. I can rewrite this so it has the same denominator by multiplying by 5 over 5. So this is like 3/5 plus 25/5. So that's going to be, remember now that I have the same denominator, I just keep the denominator and I add the numerators is 28/5. So this is now saying y equals negative 1/5 x plus 28/5. And that would be my equation of the perpendicular line that is perpendicular to this given line and passes through this point, 3, 5. Okay. All right, and I think the last page is a blank. Yep. Okay, so that's it for section 2.2. What we'll do next is probably jump to section 2.4, which is on complex numbers. Great, thanks.